Good afternoon, and welcome back to Dr. Logic Awkwardly Does Logic and answers all of your questions. It's been a couple of weeks since we talked about variable assignments and truth and semantics and things like that, but I've been getting some feedback that indicates that people are maybe not still quite getting exactly what's going on about with variable assignments. So I'm going to talk about that some more, hopefully in a way that will help you to understand what these are doing and how they interact with the notion of truth. So in order to do that, I've put up a little toy example on our whiteboard already. So we can take a look at our domain, which has these three shapes. So there's an empty blue square, an empty blue circle, a filled blue square, a filled red circle, an empty red circle, and a red star. And then we have an interpretation, which in this case actually kind of uses mnemonic letters to pick out concepts that you can kind of easily see why they work. So the interpretation of B is the blue objects, the interpretation of R is the red ones, the interpretation of C are the circles, the interpretation of S is the star, and then the interpretation of Q, because we've already used S for star, are the squares. And then we have a variable assignment that assigns to X the filled blue square, to Y the red star, and then everything else is arbitrary because the sentences that I'm going to look at only involve X's and Y's. So what the variable assignment does with the other ones doesn't really matter. Now, my advice when looking at sentences or formulas written in the predicate logic language and determining whether or not they're true is first do an intuitive translation sort of steps. So this one is existential quantifier with the x variable, predicate x, and variable s. Predicate s, variable x. So the first pass way of reading this would be there is an x such that s of x. So this is kind of still using mostly logical vocabulary. But then you can kind of take it one step further and translate it into something that sounds a little bit more like English that says something is, and then, something is S. Or what you can do, kind of using the intuitive understanding that I've given, something is a star. And again, thinking about just abstract away from the definitions, from all of the formal machinery and the if and only ifs and the variable assignments and all of this, and just ask yourself, well, what would it mean? What would you need to have in order for this to be true? Well, what we would need is for the interpretation of S to be non empty. So if it is non empty, then there is something that is in it. Something is a star. And if you go and you look at our interpretation as we've given it here, in fact, there is something in it, it's the star. But now we want to figure out how to make this explicit using the definitions of truth that we have. And that's where the notion of the variable assignment comes in. So first, just kind of take a look at this open formula. So x is a free variable. It's not bound by any quantifier. And at this point, then, in order to tell, I should put a question mark here because we'd be asking, is it the case that Sx is true on this model and this variable assignment? The way that you would figure this out is you would look at, well, what is assigned to X? It's the blue square. Is that thing in the interpretation of S? So this is the case. Oops, there we go. If and only if whatever the variable assignment assigns to X is a member of the interpretation of S. But right now, what it's assigned to by this variable assignment is the blue square. So what we could say, the blue square is not in the interpretation of S. So this formula, Sx, is not true. You might be sitting here thinking, but wait, we just said, so long as the interpretation of S is non-empty, then there is something that is S. That is what the variable assignments and shifting to x variance or y variance does. What this says is, okay, it needn't be the thing that is assigned to x right now that is s, but can I find something in my domain that is in the interpretation of s? So essentially the question is, can I find a value of, yeah, let me find a different a nicer way of saying, can I find an object in my domain such that if a variable assignment assigned assignment assigned that object to x, then s of x would be true. So right now it's not true because x is picking out this filled blue square. But we could change variable assignments. And we can do it in a particular way. We can change the variable assignment just in terms of what x picks out. And that is the notion of an x variant. So take the x variant v prime, where v prime of x is the red star. Then we have something that is in the interpretation of x. And therefore, we can say that on the variable assignment v prime in this model, that this sentence is true. Sorry, this is a formula, not a sentence. It has a free variable. So this is the case. So this is the case. Now go back to this existential quantifier. It just says, is there a variable assignment that makes it true? And the answer is yes. And in particular, it's the right kind of variable assignment because it's an x variant. The only thing that we have changed is x. So I'm gonna clean up a bunch of stuff on the board so that we've got space to talk through the next one. So with the existential quantifier, it doesn't matter what your variable assignment assigns to the variable that you're quantifying over. All that matters is, can you find a variable assignment? So can you find an object in your domain that has the right kind of properties that would make your formula true? Let's look at this next one. This one does not have any quantifiers. It's just an open formula, by. So it's not a sentence. It has a free variable in it. So again, we know that by is going to be true if and only if whatever the variable assignment assigns to y is a member of the interpretation of b. So that's the case if and only if the star, because that's what the variable assignment assigns to y, is a member of the interpretation of b. But if you go and you look at the interpretation of b, the red star does not occur there at all. So that means that this is not a member of that. Therefore, v of y is not in the interpretation of b. And therefore, we know that this is false. And at this point, we stop because the question just was, is it the case that what the variable assignment assigns to y is in the interpretation of b? The answer is no, full stop. It's only when you have the quantifiers that you shift to a different variant. So this was a fairly straightforward example. Let's look at just one more. This one, which says that for every x, there is a y. X is both s and b, and y is q. So this is saying that everything is so you can kind of separate out these two bits. You've got the stuff that's talking about the x's and the stuff that's talking about the y's. So the x's are saying essentially everything is a blue star. And then the other conjunct is saying that something is a square. So here, what we would be looking at is, let me say it a different way. Let's start off with the formula without any quantifiers and just ask ourselves, what's the status of this one? So Sx and Bx and Qy. This is true if and only if whatever the variable assignment assigns to x is in the interpretation of S, and whatever the variable assignment assigns to x is in the interpretation of B, and whatever the variable assignment assigns to y is in the interpretation of Q. So we can check each one of these. V of x, as we've said before, is the filled blue square. So that would be the same as saying the filled blue square is in the interpretation of S. And then we have that the filled blue square is in the interpretation of B. And now what does V assign to Y? It assigns the red square. So this last one, sorry, not red square, red star. This last one says that the red star is in the interpretation of Q. Now, if you look at each one of these, the blue square is not in the interpretation of S, so that one's false. It is in the interpretation of B, so that's good. And then we have the red star, which is not in the interpretation of Q, so that's also problematic. So right now, this sentence is false. Sorry, it's not a sentence, it's a formula. This formula is false. If we wanted to look at it from the point of view of quantifiers, though, we actually need to say, okay, first of all, is there something that could be assigned to y that would make qy true? So thinking about y variance. Well, yes, because there's these two squares right now. So we can make exists y, sx, and bx, and qy true if we shift the y, if we shift to a y variant that takes y to one of these two squares. But then you can kind of say, okay, that's fixed. So we've got our blue squares here, and that's what's going to be making this thing true. But now we still have this issue of needing to make this first conjunct true, which says no matter what variable assignment you pick, that's what the for all means, it will always be the case that the thing you pick is both a square and blue. Now, right away, you should see that we have a problem here. Because in order to make this one true, we need y to be assigned to a square. In order to make this one true, we need to make x be assigned to the star. But this means that take the variable assignment that assigns y to one of the squares, that very variable assignment will make it not assigned to one of the stars. So here, this is going to end up being false because, so you just write this out. It is false that for every x, there is a y. X is S and B, and Y is Q. because no variable assignment sorry, some variable assignment will make Sx and Bx false. Namely, by assigning to X whatever Y gets assigned to. So the important part here is that we are looking at every single possible variable assignment. So we have to consider the case where X is assigned to the empty blue square, the empty blue circle, or the filled blue square, or the filled red circle, or the empty red circle, or the red star. So we have to go through each one of these to see whether we could find something that would make it work. And given that there are things which are neither stars nor blue, we know that ultimately this formula is going to end up being false. So I hope this helps you get a better sense of like when to use the variable assignments, why we are shifting from one to another, what the purpose of the variable assignment is. And that's just because if you have a formula that doesn't have every variable quantified, so if you've got free occurrences of your variables, you have to know what those variables pick out in order to be able to evaluate whether or not that formula is true. And you need to be able to do that before you can go on and evaluate the truth of the quantified formula. So that's why we have variable assignments and the role that they play. And hopefully this will be a helpful example for you if you're still kind of struggling with these notions. Don't worry, next time we'll get back to proof theory. Take care and see you then. Cheers.